Hi, my name is Brian Liu. I'm in period 2 of AP Calculus BC, and today I will be doing a 2014 AP Calc BC FRQ number 6.
So let's take a look at the problem. Number 6 states that the Taylor series for a function f about x equals 1 is given by the summation of negative 1 to the n plus 1 times 2 to the n over n times x minus 1 to the n, and converges to f of x for the absolute value of x minus 1 is less than r, where r is the radius of convergence for the Taylor series. A asks to find the value of r.
So the summation given to us is the summation of from n equals 1 to infinity of negative 1 to the n plus 1 times 2 to the n over n times x minus 1 to the n. So you really have two options here. You could either, one, use the root test, or two, use the ratio test to find the radius of convergence. So I typically like to use the root test because I have found it to be a lot easier to use than the ratio test. So the root test states that you take the limit as n approaches infinity of the nth root of all of this, and if this is less than 1, then it is convergent. If it equals 1, then the test is inconclusive. And if it's greater than 1, then it's divergent. So this would become 2 times x minus 1 over n to the 1 over n. So because you have this n to the 1 over n, you got to rewrite this as y equals the limit as n approaches infinity of n to the 1 over n. You can then proceed to ln both sides. And bring down the 1 over n because it's ln of n. So this would become ln y equals the limit as n approaches infinity of ln n over n. So this would become infinity over n infinity. Because this is infinity over infinity, you can use L'Hopital's rule and take a derivative of both the top and the bottom. So this would become 1 over n over 1. And 1 over infinity over 1 is just 0. So ln of y is 0. So y equals e to the 0, which is 1. So you just proved that the limit as n approaches infinity of n to the 1 over n is 1. So because you've established that the limit as n approaches infinity of n to the 1 over n equals 1, you could plug that into the original function and get this. 2 times x minus 1. And then you have to remember to put the absolute value signs is less than 1 because you're testing for the radius of convergence. And it's convergent when all of this is less than 1. So the absolute value of x minus 1 is less than 1/2. And in the original problem, it says the absolute value of x minus 1 is less than the radius of convergence. So you have essentially mirrored this. So this is equal to your r. So the radius of convergence is 1/2. Part B asks to find the first 3 non-zero terms in the general term of the Taylor series for f prime, the derivative of f about x equals 1. So you're given f. F is the summation of negative 1 to the n plus 1 times 2 to the n over n times x minus 1 to the n. So to take the derivative, you pretty much just do what you do when solving a regular problem. So 2 to the n just stays the same because this is just a constant. And because this term has an x in it, you need to subtract 1 from the power and drop it down. So you're going to do x minus 1 to the n minus 1 because you're subtracting a power. That's the definition of a derivative, times n because you need to drop down a power. So the n's cancel out, and you're left with the summation from n equals 1 to infinity of 2n times x minus 1 to the n minus 1. So the general term for f prime is negative 1 to the n plus 1 times 2 to the n times x minus 1 to the n minus 1. For the first three non-zero terms, you just plug in n equals 1, n equals 2, and n equals 3. And you get 2 minus 4 times x minus 1 plus 8 times x minus 1 squared. So this would be the first three non-zero terms for f prime.
So part C asks, the Taylor series for f prime about x equals 1, found in part B, is a geometric series. Find the function f prime to which the series converges for the absolute value of x minus 1 is less than r. Use this function to determine f for the absolute value of x minus 1 is less than r.
So in part B, we found that the general term was negative 1 to the n plus 1 times 2 to the n times x minus 1 to the n minus 1. So part C says that this is a geometric series. So you can use the form a over 1 minus r of x to see what it converges to. So a is the first term, or the initial term, and r of x is just a ratio between successive terms. So in part B, you found out the first term was 2. So 2 would be your a, which is also your first term. R of x is the ratio between successive terms. So negative 1 to the n plus 2 times 2 to the n plus 1 times x minus 1 to the n over negative 1 to the n plus 1 times 2 to the n times x minus 1 to the n minus 1. So essentially, you're taking this and you're adding 1 to each of the n's and putting it over the original. So this is what your ratio would be. And this all equals negative 2 times x minus 1, or negative 2x plus 2. So your r of x is just negative 2x plus 2. So this would be, so the form a over 1 minus r of x is just 2 over 1 minus negative 2x plus 2, which is equal to 2 over 2x minus 1. So now that you know that f prime equals 2 over 2x minus 1, you know that f of x equals the integral of 2 over 2x minus 1, or 2 times the integral of 1 over 2x minus 1 dx. So over here, you can do a simple u sum. So you can let u equals 2x minus 1 du equals 2 dx. So this would be 1 over u du times 2 times 1/2, because you need a 2 here, and once you put a 2 here to balance this by putting 1/2 here. So the 1/2 and the 2 end up canceling out. So this will become ln of u plus c, or ln of 2x minus 1 plus c. So this would be your f of x. F of 1 equals 0. So you can write it out just like y equals ln of 2x minus 1 plus c. And you can plug in 1 for x and 0 for y. So you get 0 equals ln of 1 plus c, in which case c is just 0 because ln of 1 is 0. So your f of x is just going to be ln of 2x minus 1. And that is your answer for part C. Here are some extra practice problems if you want to perfect the art of Taylor series. Thank you for watching my video, and I hope you have a good day.